Hello, wonderful. Let me start that over.
Hello,
wonderful
again?
7th graders.
I gave it my intro and you just
Guess who you have here? Do you think it's your science teachers? Your English teacher? Guys, it's Miss Newsome.
Miss Green.
And Coach Groves, the most amazing, wonderful math teachers ever. We are your favorites out of all the subjects, even science.
Don't lie.
Yeah, your science teachers aren't cool.
Hey, wait, hold on, that's me. Hold on.
Yeah, no,
I thought you said social studies.
No.
Whew, moving on.
Hey, today we're still talking two-step equations. I know we've been talking about this for a few days. You're starting to be on your own. I know I've told my kids I'm releasing you into the wild. I'm not holding your hand anymore. We're still going to keep going. We do have a test tomorrow, which would be Wednesday. Your test will be on Wednesday. You're probably watching this video hopefully over the weekend like a good student that I know you are. So we're going to talk about this. Our learning target today, we will be able to write and solve two-step equations by using inverse operations. What did we say inverse meant?
Well, I don't know what you guys said, but I think it means the opposite.
That's what
right?
I've told them.
Yes.
Inverse means do the opposite operation.
Right.
So what was the inverse of addition?
Subtraction.
The inverse of multiplication?
Division.
The inverse of subtraction?
Is addition.
And the inverse of division?
Is multiplication.
Okay, so we've got all those inverses down. You know them, you love them, you remember them. Don't forget them. Opposites. Woo. Now, let's start with model 3x plus 2 equals 8. So I'm going to use the algebra tiles, and then we can show you Miss Green's little pluses and minuses, and I don't even know what we call
Hey,
those.
I used that too, because my kids
That's okay.
really like that. And I told them
Yes.
that was Miss Green. But if you
Um,
like Miss Green's way, then do it.
And that's what I said. Whatever way works for you, I
Yeah.
don't care what way you use. Use whatever you want. I'm going to show you multiple ways. As I said right now, I'm going to show you all of them. So if we did algebra tiles, we've got 3 x's, 2, 3, and then we've got plus 2.
Little boxes.
Little boxes equals 8.
This is why going to the computer lab and doing that modeling activity was so important.
Yes. So these are all little pluses. This is, all I said was to model. I didn't say to solve. I just said to model. That's that equation modeled as with algebra tiles.
Modeled.
Hold on, isn't the answer just 2?
Oh.
Well, how would you get that? Because I don't even know where your work is and what you did, and I
3
can't.
times 2 is 6 plus 2 is 8.
But
Well, there's
but
logical
I-
steps that we have to solve to get it.
I get that
you
you-
have to show your work.
Yeah, I get that you understand how to do it, but I want to see by inverse operations how to do it. Because when we get to 8th grade and algebra, it's not going to be that easy.
So I can't just write x equals to 2.
No, you may not.
You need to show your
But
work.
what if I do that on my on my test?
I'm going to give you a 0.
You have to show your work so we know that you can solve by using the inverse operation.
You have to show your work to get credit.
How many times do we have to tell you, Green?
Oh my gosh, Miss Green.
I just want to write x equals to 2.
Nope.
Maybe it doesn't though, because you didn't solve it.
We're
you
going
didn't
to
prove.
move on, and we're going to continue to model this equation the way Miss Green does. We've got 3 little x's, and we've got, is this how I do this with plus 2? And then, am I doing this right?
Yes, and then 8 positive pluses. Well, obviously pluses would be positive.
Is that how I do it right?
Uh-huh. Good job.
Okay, did I model it correctly for you, Miss Green? Mm-hmm. Okay, perfect. So that's the same model. They mean the same thing. Sometimes when I've seen it on some like other things where they put circles and they put it in circles, and that's okay too. Pay attention to what's going on.
Got it. That's just the modeling.
That's just the modeling.
No solving.
Now, we've got 331 students went on a field trip. 6 buses were filled and 7 students traveled in cars. How many students were in each bus? Now we've got to think. Last week, we did writing. Well, the week before last, we did writing of equations.
Yes.
So now, I want you to write and solve. I'm throwing this all together.
We're throwing it all
Nice.
together.
So we have 331 students went on the field trip. 6 buses were filled to capacity, and 7 students traveled in cars. So how am I going to write this equation?
So there's
What's
the
our
same,
variable?
It's the same on each side.
It has to be equal on the same.
Okay, just
on it.
making sure.
Yeah. What's our variable?
What
are we looking for?
How many students were on each bus?
So the X would be students on bus.
So right now, I think you're identifying all the information.
I am identifying all the important information.
Okay.
So the students on the bus is X. What other information do we have about those students that went to this field trip?
We know how many buses there were.
There were 6 buses.
We know how many total students there were.
We know there was a total of 331 students. And we also know what?
7 students traveled separately in the cars.
7 in cars.
Yes.
So now let me put all this together. I want to know how many students are on buses, and there were 6 buses. So if I had a certain number of buses with students on them, how do I figure out how many were on a bus? What operation would I
I
use?
think you would divide to see how many would
Not divide.
go into each bus.
That would be if I had the students.
Oh, if you had, oh right, that's right. If you had the students, okay.
So if I have 6 buses and there are a certain number of students on each bus, wouldn't I multiply that?
to find the total number of students
That were on the buses.
Yes.
So would I have 6x?
Yes. Perfect. Because there's 6 buses. We want to know how many were on each bus.
It's like a disco ball in here.
Yay.
So now we've got 6 buses filled with students. This is the students on the buses, so 6 times the students on the buses. Now, how many are in cars?
7 students are
So
in cars.
plus 7 extra students equals a total of how many students?
331.
I was so confused. I kept thinking we were doing a multi-step equation.
I was too.
I should go home, y'all. I'm so sick.
I'm not. I don't have an excuse. So
Gosh, I'm so.
It's a good thing I'm here.
Yeah, I was.
thank
confused.
God Groves is here.
I was thinking multi-step equations. I'm sorry, y'all.
That's okay. That's what pre-AP's doing. That's why she's thinking it.
I know.
Now, we've got 6x plus 7 equals 331. What was step 1?
Step 1 would be to eliminate the constant.
The constant, remember, guys, is the number on the side with the variable that is
Not
all
attached.
by itself. It's not attached to the variable. So what is my constant?
What? The 7.
Okay.
So what is the 6?
The 6 is the coefficient.
Can we label that real quick just so that they can see that?
Coefficient.
We did that today in our notes. So my kids, if you need help, if you need to go back to your notes and look, you should have a 2-step equation with everything labeled.
Coefficient and constant.
So what?
make
What
no
would?
guarantees
What
I
was my?
spelled that right.
What would the x be called?
The variable.
There we go.
Man, you write small.
I know.
No.
I'm sorry. I'm trying to. You added that in. I didn't have room. Anyway, so now we're going to eliminate our constant. How do we eliminate positive 7?
You want
Do the
to, you want to
inverse.
Inverse operation, which is subtraction. That cancels out. Minus 7. 331 minus 7 is?
324.
324.
That's Alicia Newsom.
Yes.
She's our human calculator.
She is. And we divide that by 6. Divide
good
by
at that.
6. What do I
Yes,
do?
ma'am.
Miss Newsom?
You put top dog in the house and you divide by 6. We're gonna have to divide.
You're going to make me divide. 6
All right.
goes into 32 5 times. That's 30. Bring down the
24
24
times.
is 4 times. So there are 54 students on each bus.
Good deal.
Make sense? Mm-hmm. Now, Aaliyah had $24 to spend on 7 pencils. After buying them, she had $10. How much did each pencil cost?
Okay.
So what are we looking for? What's our variable?
The cost of the pencil.
So pencil cost.
Yes.
What other information do we had?
We know that she spent
Half.
Half? Oh, okay, listen. Whew. We know that she spent She had $24 to spend,
So she had $24 total.
and she had $10 left after she purchased the pencil.
So $10 left. And so we're looking for how much it's left. Do we know how many pencils she bought?
Yes.
How many?
7.
She bought 7
Look
pencils.
at that. You snuck that in there.
I
didn't see that.
did. I did. You see that? So now, if we're looking for cost, that's what we're looking for. What am I going to multiply the cost of a pencil by?
Probably by the number of pencils that you have.
The number of pencils I have. So am
Yeah.
I going to have 7x?
Sounds good.
And then what do you think's next?
You gotta find that add that constant in there.
Is it going to be the 24 total?
No, that's
Or
going to
the
be on the
10
other side of the
left.
equal sign.
Am I going to be subtracting the 10 or am I going to be adding the 10?
Oh, I believe in this case you're going to be adding the 10.
You're adding the 10
Can you
because
explain to them why?
it's left over. The cost of these pencils and the cost of the pencils times 7 is going to equal plus 10 is going to equal a total of $24.
Okay, so you're counting for that positive 10 to be left back in her pocket once she's done.
She's still got that in her pocket.
Perfect.
So this is how much the pencils cost. This is how much she had left. That total was $24.
I wouldn't have done it that way, but it works.
Okay.
Oh yeah, it totally works.
Now, what is my constant?
Well, obviously, it's going to be 10.
Okay, so how am I going to eliminate 10?
Since it's being added, the inverse operation is going to be subtracted on both sides.
24 minus 10 is 14. I can do that one on my own.
Ooh, good. Quick thinking.
Then my inverse operation of multiplication is division.
Yep.
Divide by 7, x equals 2. So she bought, or the cost of a pencil was $2 a piece.
Ooh.
That's an expensive
$2
pencil.
per pencil?
Probably mechanical.
It probably was.
But hey, she had $10 left over when she left.
She did have $10 left over.
Okay, and also, had I written it differently, because that's not how I would have written it. I was actually a little confused at the beginning. May I borrow your-
I was a little too, but
Because I know I have $24 to spend, and I bought 7.
for a cost.
Right, and that equals to 10. So let me just go ahead and separate this so y'all can see. That also works. So in case you're wondering, because I was a little confused with what she was doing, but they're the exact same thing.
Yes.
She had $24 to spend. She bought 7 pencils. So if you buy something, you're taking that money away. So she bought 7 pencils at this cost.
You still
and
keep the variable because you still don't know.
Right, we still don't know, and then we ended up with $10. So this also works.
And the reason I did mine
I
the way
think because
I
it
do
looks pretty and it look.
Well, the reason I
looks
do
like
it
they see it
is
too.
actually because it said she had a total of $24.
So you
And
know
so
that
I
that
think
should
total
equal.
is equal sign. So I always put it on the other side of the equal sign.
Either way,
Either
will
way
we
it
get the
works.
same answer?
Yeah.
Yes, we will.
Okay, so
Go ahead and.
if we were to just do subtract 24 from each side, I would be left with negative 7x. Don't forget that negative belongs to the 7x.
Yes.
And then 10 minus 24 is negative 14. Divide each side by negative 7. That's a negative, y'all know.
Negative divided by negative
That's
is going to
right.
give you a.
X equals 2.
to 2. So these are the exact same thing. Hey, we're different teachers. We
Yeah.
teach differently and
Yep.
we learn differently. This is how I would have done
You
it.
guys
This is
are the
how she did
same.
it. And we
Yep.
get the exact same answer. And you know
Exactly.
what? It doesn't matter which way you do as long as you understand.
I like that this one didn't have negatives.
You're right.
Yeah, it looks good and it looks clean. I
Yep.
like that
I think
too.
mine looks more.
Anyways,
it
we
looks-
are out for today. I hope you have a wonderful day.
Hey, wait. Let me just. Yeah, she was finishing, and then.
I'm sorry.
It looks more mathy.
Yeah. Yeah. Okay.
Mine
hold
looks
on.
mathy
Hold on.
too. Okay. Peace out, y'all. Good luck on your test tomorrow.